Hello, everyone. My name is Rohan Shah. I'm a director of software engineering here at United Airlines. Really excited to be here as part of the EDA Summit and share our story about our mainframe modernization using event-driven hybrid cloud architecture. Also, I have Hemal Jani here with me, who's a senior solution architect from AWS, and he'll be walking you through some of the architecture pattern that we have enabled using technologies like AWS and Solus. So let's move on. And before we dive further, let me tell you a little bit more about myself and what my team does. I'm responsible for modernizing the architecture of our current PSS system. Now, those who are not familiar with airline must be wondering, what is PSS? It's a platform that manages various aspects of passenger-related activities, such as reservation, ticketing, boarding, baggage handling, and customer data management. Simply, it's the brain behind an airline operation, ensuring smooth passenger experience from the time of its booking to boarding. Think of it as a critical system or critical central system that handles all those behind the scene related tasks for a passenger service for an airline. Now, just to add more color to the PSS, it is 50-year-old system, 50-year-old mainframe system built on a 50-year-old technology called TPF. Now, many of you are hearing for the first time what exactly TPF is. This mainframe system today, it's highly reliable, very fast, and powers some of the critical United systems, including our industry-leading mobile app. But like any other mainframe, it has its own challenges, which we're going to talk about in the next slide. Now, when you look at this architecture, the first thing comes to your mind is how complex it is. So it's like all functionality are packed in one single box and highly intertwined with each other. So difficult to make any kind of changes before impacting another areas. So anytime we have to do a change, we have to do a lot of planning. We have to do a lot of testing planning, as well as, and kind of lose on the opportunity to move fast. Plus, it's hard to find people who knows TPF programming experience. They don't teach you anymore in the college or university. So it kind of becomes very difficult to maintain, as well as it's highly complex. I'd like to start with a little bit of story before we dive further into modernization strategy. During the pandemic, while other airlines were downsizing, we saw an opportunity and be the #1 airline in the world. We ordered 700 new aircrafts, delivering over the next 5 years. That means also creating 50,000 new jobs. If I put that into an equation, we will be 3 times of the size of what we are today. That means more passenger and even more user and operational traffic. So we needed a solution that allow us to scale our system as we add new aircraft, new flights, new bags, or more seats, and more gates, and even more employees. In 2020, United made a commitment to move 100% of its critical infrastructure to AWS within the next 5 years, while making sure that we are not doing any kind of lift and shift. Rather, we are refactoring to meet our business needs. We are well above or on track to meet that goal. We are at about 60% today. And you can hear more about the story of our cloud migration from our leaders directly by scanning this QR code on the screen. Now, earlier I talked to you about our PSS modernization. So let's talk about how we are doing it and how it's going to look tomorrow. So we decided to take a drastically different approach from our competitors by moving one piece at a time and modernizing using cloud native technology that are loosely connect all business domain using event-driven architecture. The first place where we started was seats. Now, seats is a very complex problem to solve. And it's significant contributor to our ancillary revenue, as well as our customer NPS score, because it quite matter a lot to our customer that, the day of travel, where they're going to sit, are they going to sit together or they're going to sit separate? So it's a very critical problem to solve. All right, so let's talk number. About 500 to 600K passengers fly with United. We manage about 1.7 million flights at any given point of time. 80 different seats map, or 90 different seats maps now. And it has a high volume system that performs about 15 million transactions per day. Now, on the right side, it talks about the key business requirement. And as I explained earlier, seats is a very complex and it's kind of drive our NPS score. That means we want to make sure that our systems are always available for our customer to make changes. And that requires high resiliency. We should be able to fail over from one region to another with no downtime. Having visibility into end-to-end transaction, making sure that the transaction was successful, and we should be very proactive in case there any kind of anomaly or any kind of problem with the overall platform. We should be able to maintain interoperability between both system on new and old. We should be able to backward compatible. And Hemal is going to talk to you about more about how we are achieving this. Plus, it was very important for us to kind of not taking any kind of big bang approach, rather taking a small step, moving one piece at a time. And for that reason, it was important for us to maintain the data integrity between the new system as well as the old one. And the other two, like cost and security, are the key pillar for our overall architecture. And with that, I'll pass it on to Hemal, who will walk you through how we are accomplishing this key business requirement.
Thank you, Rohan, and hello, everyone. In this second part of this presentation, I want to focus on the architecture patterns which were used by United Airlines to modernize critical systems. As Rohan mentioned, today we're going to focus on seats inventory system, which has a high impact on customer satisfaction. The architecture pattern discussed in this presentation can be used by anyone who's on a similar journey. So we are going to discuss what these patterns are, why did United decide to take advantage of them, and how can you learn more about these patterns. As we go along, I will share some white papers and blogs, which will dive deeper into the concepts and give you additional resources to get started. Before we dive in, a quick introduction. So my name is Hemal Jani. I'm part of a solution architecture team at Amazon Web Services. I've been with AWS for 5+ years, and out of that, I've been helping United Airlines for more than 3 years. It's been an interesting journey so far, with unexpected challenges like COVID impacting the aviation industry at large. But in the end, it is a great learning experience for me working with United Airlines. It's amazing what United has achieved over the past couple of years. With that, let's dive in. First, let's summarize quickly the requirements and business challenges Rohan laid out in his presentation. He spoke about availability, observability, agility, and interoperability. In addition to these fundamentals, United had other considerations. For example, dependency on a tightly integrated mainframe system. They did not have the luxury of starting something new on AWS. United wanted to take advantage of AWS purpose-driven databases, which suppose diverse data models and allows them to build data-driven, highly scalable and distributed applications. A resilient architecture, which fully integrated with the mainframe system. To explain United approach, let's dive into 4 architecture patterns. Application modernization typically involves 2 types of project, a brownfield project and a greenfield. Brownfield project involves development and deployment of new software systems within the context of an existing one, whereas greenfield involves creating a system from scratch for a completely new requirement without any dependency on the legacy code. One of the first steps of application modernization journey is to decompose the monolith into microservices. We'll look at that pattern first. Second, we'll talk about the mainframe integration pattern, which facilitates data replication from mainframe system to AWS data stores. This is becoming very popular pattern, especially if we are looking to coexist AWS native applications with mainframe systems, basically hybrid applications. Third, we'll talk about data persistency for your microservices. We will see an example architecture which helps you choose your data storage technology based on data access patterns and other requirements of your microservices. Finally, we're going to talk about resiliency. United's current solution challenges with that solution, and how AWS and partners are trying to solve these challenges. If these are the topic of interest, please stick around. We're going to have fun. Let's start with the first one, decomposition of monolith into microservices. Most applications are built as monolith. A tightly integrated system serves a specific business functionality and is usually a single unit of deployment. Although a monolith can be a valid option for some use cases, it's typically not as suitable for modern applications, which are designed to be loosely coupled and supports continuous deployments. To break down the monolith into smaller microservices, there are many well-known patterns. For example, decompose by business capability. You can use your organization's business processes or capabilities to decompose a monolith. It works well if business capabilities are relatively stable, but requires an in-depth understanding of the overall business. In some large organizations, it can become difficult to identify business capabilities and services. You will find a lot of overlaps there. Another example is service by team pattern. Each team is responsible for its business capability, owns the capability code base, and delivers it for the business. But many of these patterns are more suitable for greenfield projects. Applying these patterns when the system is still operational makes this process difficult. Strangler fit pattern, introduced by Martin Fowler, is used to incrementally transform a monolith application into microservice by replacing a particular functionality or feature into a new service. Strangler pattern is useful for breaking monolith mainframe environments in modules that can be refactored one at a time to a new target platform. The PSS mainframe application is naturally segmented into various business functions like reservations, seating, bags, etc. This makes it a prime candidate for a strangler pattern. Let's double click into this pattern a little bit. Remember the goal of the legacy, and remember the goal is for the legacy and the new modernized version to coexist. The new system is initially supported by the existing system. This support gives the new system time to grow and potentially replace the old system entirely. Now, there are three distinct phases to this pattern. First is transform. Transform means identifying and modernizing the component by porting or rewriting the code base. In United's case, we are talking about seats. Seats was the first business functionality identified by United and migrated to AWS. Second, coexist. Move the business functionality to a modern application routing the HTTP calls via a proxy like API gateway. So once the service is on AWS, you can route everything via an API gateway, and both of them can coexist. However, there are certain considerations that you need to be aware of. First is network traffic. If you have a chatty application going back to on-premise, that will increase your data network traffic, which has a direct impact on your spend. So there are certain best practices to limit the chattiness of the application and dependency on the monolith, which is coexisting with the modern application on AWS. The last phase of this is the eliminate phase. Retire the old functionality from the monolith as traffic is redirected away from the monolith to a modernized service. At this point in time, it's safe to decommission the mainframe system, moving completely to a modern application state, focusing organizations' valuable resources on business innovation. As I mentioned earlier, I'm going to give you certain white papers as the link over there, which will give you much deeper understanding of what the strangler fit pattern is all about. At the end of the slide, I will also give you a QR code which you can scan and take a snapshot of the QR code. So let's zoom out. This is how strangler fit modernization strategy will look like. You identify the workload on the mainframe and one by one move that workload onto AWS. Let's talk about the second pattern, the mainframe data integration. So United is building a system of engagement on AWS. The goal is to build personalized engagement channels for customers. However, the system of record still remains on-premise locked in a mainframe system. With a message-oriented middleware system like IBM MQ, you can unlock this data to replicate it to AWS data stores like DynamoDB. AWS native services like Amazon MQ, which is a managed Apache MQ, Amazon MSK, which is a managed Kafka, and partner solutions like Solace. You can use them as the streaming data services, which provides critical infrastructure for this pattern. Mainframe transactions from IBM MQ can be read using a connector or a bridge solution. This can be published to Amazon MQ, Solace, or Kafka topics or queues. Once the data is published to the queue or topic, consumers running either on a compute service like Lambda or a containerized service like Elastic Compute Service or managed Kubernetes service can process, map, transform, and filter these messages and eventually committing them into a database. This mainframe data integration using AWS services enables you to reduce cost, create modern application, and integrate your mainframe and cloud native technologies together. Some of the key capabilities of these, if this pattern is requirements like JMS protocol, support for JMS protocol integration, some strong ordering, rule-based, message queuing, cross-region capabilities, and which we'll talk about in the upcoming slide, and ability to replay these messages in case of a failure. And most important, once this pattern is established, many customers, including United, will look at analytics to take a snapshot of the messages and run analytics on top of that. Let's jump to this third architecture pattern used by United, the data persistency using the CQRS pattern. Now, United has business requirements like schedule changes happening every week, which assigns passengers to aircraft. These changes generate a lot of traffic, and which means generates a lot of write operations onto the database. Many of the times, the write requirements and the read requirements are different. CQRS is used when you want to scale your workload that way. This pattern allows the read and write workload to scale independently. May also result in fewer lock contentions. In this example architecture that you see on the slide, a NoSQL data store like DynamoDB is used to optimize the write throughput and provides flexible query capabilities. This achieves high write scalability on the workload that has a well-defined access pattern when you add data. A relational database like Aurora provides complex query functionalities. Amazon MSK is used for data transformation, and that updates the Aurora database. Let's talk about the last architecture pattern, which is the resiliency, which is the core requirement for United Airlines. Now, a resilient workload has the capability to recover when stressed by load or a failure of component. Failures happen all the time, and being resilient in two different regions and testing it out is a core requirement for any application, critical application running on AWS. In this example, which I'm showing, which is representing IBM MQ sending messages to Kafka, and the consumers are consuming these messages. However, if you want to replicate these messages into a secondary region, there is technology out there called Mirror-Maker 2.0. United has implemented this as part of the seats inventory application. Currently, they have implemented this on an EKS cluster. So Mirrormaker will replicate each and every event onto a secondary region and make it available into a Kafka queue in the secondary region. In case of a failure, IBM MQ will switch over to the secondary region, sending newer events to the secondary region so that the events can be processed while you recover from the in the first region. However, there are challenges. As I mentioned, United currently is running this on an EKS cluster, which means they are managing their own Mirrormaker implementation, which has its own operational challenges. You require expertise in Mirrormaker software, and you will have to update the code base. It's an operational challenge. To overcome these operational challenges, United Airlines is working with AWS partner solution like Solace. Solace is available in AWS Marketplace. You can acquire it via the Marketplace solution. Solace has a hybrid cross-region multi-AZ broker implementation. So you can basically create an event mesh with your existing implementation and still achieve cross-region. One of the key benefits of using a solution like Solace is minimum client configuration. So Solace exposes an API which you can tap into to fail over the broker into a secondary region. United is currently working with Solace for this implementation. Now, as I promised, here are the 3 white papers, blogs, which you can, which will give you additional information on the concepts. Take a pause the video, scan the QR code, and make good use of it. With that, thank you very much. It was a pleasure speaking about United Airlines and AWS journey together. Thank you.